Let's solve LeetCode number 808, soup servings. So we're given two soups, A and B, each starting with n milliliters of liquid. Now on every turn, one of the following four things can happen randomly, each with an equal probability of happening. So either we'll pour 100 milliliters from A and 0 from B, 75 from A and 25 from B, 50 from each, or 25 from A and 75 from B. We stop whenever one or both of the soups runs out, and we want to return the probability that soup A runs out before soup B, plus half the probability that they both run out at the same time. It also says answers within 10 to the negative fifth of the actual probability will be accepted, so we don't have to be exactly perfect to get the right answer. So let's take a look at an example. Let's say we have 50 milliliters of each soup, and now let's remember our four options. So in either of the first two options, if we pour 100 milliliters or 75 milliliters of A, then that's more than 50, so we're definitely going to run out of soup A before soup B, so there's a 100% chance in each of those two cases. In option 3, we pour 50 milliliters from A and 50 milliliters from B, so both soups run out at the same time, so we take half that probability, so 100% chance divided by 2 is 50%. And in option 4, we only pour 25 from A but 75 from B, so soup B runs out first, which means there is a 0% chance of soup A running out first. Then we average out the probabilities to get 2.5 divided by 4 equals 0.625, which is our answer. So we've seen with a small number of milliliters like 50, we can easily compute our answer. But let's say we started with a lot more like 200. We'd have to take multiple turns. So on the first turn, we could choose from any of the four options. Then after that, we'd have to add that to the probability of each of the four options from the next turn. So it ends up being a lot more computations, which is why this problem is perfect for dynamic programming, because we can first start out by solving with a small number of milliliters, and then as we work our way up, we can use our probabilities from our previous solutions to help us along. So let's get into the code. First, we'll create a default dictionary called DP for dynamic programming. Then we'll create a function called calculateDP, which takes the volume of A and B as parameters. If A and B have both reached 0, then we know to return a probability of 0.5. If only A has reached 0, we'll return 1, and if only B has reached 0, we'll return 0. Otherwise, if we find both values of A and B in our DP array, that means we've already solved the subproblem, so we can just return the value that we've stored in that array. Otherwise, if it's our first time seeing these values of A and B, then we need to calculate the probability by adding up the probabilities from each of the four options that we calculate from calculateDP and getting the average of those, which we'll then store in DP, which we can use for future calculations. Now that we've created this function, we can fill our DP array by calling it on every value from 1 up to n. And if we get close enough to 1, we can round up since our answer doesn't have to be exact and terminate early. Then we'll just call calculateDP, passing in n, and our DP array will do the rest of the work. If you want to learn how to improve this solution in the time and space complexity, like and follow for a part 2.